Now coming to this question number 5, which says list in increasing order all positive integers n less than or equal to 40 such that n cannot be written in the form of a square minus b square where a and b are positive integers. There can be many methods to do this question, and in fact they are only asking from first 40 natural numbers. It's not a very big deal. You may even identify numbers one after the other. That is also not very difficult task. But one of the systematic approach could be that we write this a square minus b square as a minus b into a plus b. Now, I will make few cases to check whether what numbers can be like this and what numbers cannot be like this. Let me make a list of can be and cannot be. Can be I am writing here and cannot be I am writing here, and we are looking for this thing, not this thing. Okay, so suppose a and b are consecutive integers. A and b are consecutive integer. In fact, I can take as a equal to b plus 1. In this case, first bracket will be 1, and putting a as b plus 1, this will become 2b plus 1. And here a and b both are positive integer, so b will be starting with 1, 2 and so on. Okay, so from this first case, when a is equal to b plus 1, you can check we can get all the odd numbers but not 1 because b is starting from 1. So here 2 plus 1, my first number that can be of this form is 3, and then 5, and then 7 and so on. In fact, all the odd numbers can be there in this list, which can be written as a square minus b square. Now suppose if I take a as b plus 2, that is difference of a and b as 2, then my first bracket will be 2 and my other bracket will be 2b plus 2, which is actually like 4 times b plus 1. So in this case, again, because b is starting from 1, so this will be least value will be 8 here. Again, I am writing can be. And then again, all multiple of 4 will be there. So 8, then 12, then 16 and so on till 40. They all can be written like this. So what is left out now? We have taken all the odd numbers. We have taken all those integers which are multiple of 4. In fact, among the odd numbers, I think 1 was missing, and this can be verified by this expression 2b plus 1 also, and by the fact also that the first perfect square is 1 because we are looking for positive integers. A and b are positive integers, so a square b square will be from only 1, 4, 9 and so on. So you cannot have this difference to be 1. So among this cannot be list, I think 1 has to be there, and all other odd integers will be here. Similarly, here among all multiple of 4, 4 is missing, and here you can check that 4 cannot be difference of any two perfect squares because 1 and 4 it is 3, 4 and 9 it is 5. So to have difference between two perfect squares, I think 1 and 9 can give 8, and that is the least possible difference which is multiple of 8. So 4 is also among that list which cannot be of the form a square minus b square. Now what is remaining? All the odds we have considered. We have considered multiple of 4s, multiple of 4, in which 4 was here. So whatever is what is left out is the even numbers which are not multiple of 4. So only we have to consider only those even that are not multiple of 4. That is the form 4k plus 1 or 4n, 4k plus 2 actually, 4k plus 2 form or 4n plus 2 form you can say. Now how to justify whether this will be coming in cannot be or can be? Please understand, if difference of a square minus b square is even, whether multiple of 4 or not, I think a square minus b square equal to even straight away means both a square and b square are either even or odd. And because a square, b square are the perfect squares, that means a, b are both even or odd. Okay, now I will use this result once again. I think I'll use this space here, or let me do one thing. I'll take another slide here. Okay, so we were looking for when the difference is even but multiple of 2. Okay, so in this case, I concluded that a square, b square are both even or odd. Hence, A and B are both even or odd. Now, in this scenario, using this result, that A square minus B square is equal to A minus B into A plus B. You can check. Both brackets will be even. If both are even, then also both are odd also. In both cases, these two brackets will be even. Hence, it has to be multiple of 4. It has to be multiple of 4. So there is no question, there is no chance that we may have multiple, not multiple of 4, but even integers, and we can write them as a square minus b square. In fact, there is another way of saying the same thing. You know it from number theory that if a square and b square are perfect square of odd integers, then they are of the form 8m plus 1, 8m plus 1. Then difference will be multiple of 8. And if they are perfect square of even, if they are perfect square of even, then obviously a square, b square both are 4k, 4k form. 4k, 4k form. A square, b square both are of the form 4m or 4k, you can say, and then difference will be multiple of 4. So from both scenarios, both cases, what we are trying to say, that this difference has to be at least multiple of 4. So there is no chance that we may have a number that is only multiple of 2 but not of 4, and it can be written as a square minus b square form. So in this list of cannot be, I think we should add all those numbers which are of the form 4k plus 2. Okay, so let me summarize all these answers here, as they are saying increasing order. So first is 1 here, then it will be 2, then it will be 4, okay, and then all numbers which are 4k plus 1 form. So 6, 10, 14, 18, 22, 26, and then 30, then 34, then 38. I think that is all among these first 40 natural numbers. Okay, this completes this question. I think this question was decently good question. You may get confused when you are solving under this exam pressure. Otherwise, I'll say not very difficult, but yes, little bit of confusing, because you may miss one of the numbers like 1 or 4 or some other things. So then I will say this question was decent.